In this lesson, we're going to continue the study of Algebra 1. This is our third class lesson in algebra. So far, we've covered articles 1 through 32 in our algebra book, and that puts us in lesson 2. What we're going to do in this class is simply finish the content of lesson 2, which takes us through article 38, I believe. So this lesson, this class, we're going to finish articles 16 through 38, which I believe is the content of lesson 2 in the Academy's Algebra 1 course. So what I'd like to do, let's get your notes ready. Title of the course is Algebra 1. And even though this is the third class lesson, this is lesson 2 in the online course. So let's label this as lesson 2. And today's content will be articles 33 to 38. We're going to stop at 38 because that's where lesson 2 stops in the online course. So we're just going to let this video serve lesson 2, and then we'll be done with lesson 2. All right, so let's make sure we take good notes. Make sure you have your name and date at the top of the page, the name of the course, Algebra 1, and the title for this lesson, which is articles 33 through 38. What I'd like to do to get started is just review what we've covered so far, because we've moved through quite a bit of material. We've already moved through 32 articles in, I think, 2 algebra lessons, right? We've had 2 algebra lessons. This is the third. So in 2 algebra classes, we've moved through 32 points in our algebra book. That's a lot of material. So let's just take a few minutes to review some of that. So for the first point in your notes, just write review of articles 1 to 32. Actually, what I'll do is let's review articles 1 to 15, and then we'll review articles 16 through 32, okay? Articles 1 to 15 is lesson 1. That's why I wrote it separate. And articles 16 through 32 is the first part of lesson 2. This lesson that we do today is going to be part 2 of lesson 2. All right? Make sure you're taking notes. That's your proof of study. So, starting at the beginning, we learned the definition of algebra. We talked about quantities, as we always do in mathematics, because mathematics is the study of quantity. I'm going to flip over to the textbook. We looked at quantity. We talked about the different kinds of quantity. You should be able to tell me the 2 kinds of quantity. Can you do that? Can you tell me the 2 kinds? Multitude and magnitude. Good. All right. So mathematics is the science of quantity. That means in mathematics we study multitude and magnitude. We talked about the 2 kinds of magnitude, the 2 kinds of quantity. So we did that. That's articles 1 through 4. We then talked about units and units of measure. We talked about how in a multitude, the unit of measure is natural because there's a number of things, right, in a multitude. So whatever the multitude is of, if it's a herd of sheep, 1 sheep is the natural unit of measure for that multitude. We said that in magnitudes, which are bodies, which are wholes, there is no natural unit of measure, so we have to create an artificial unit of measure. That's the purpose of tape measures and scales and all of these different measuring instruments that we have. They create for us artificial units of measurement, and we use those measures to measure the size or weight or shape of different objects. Okay, so 2 kinds of quantity, units of measure, different kinds of units. That was articles 1 through 6. We then talked about the numerical value of a quantity, and we said the numerical value of a quantity is the value of a quantity with its units taken away. The numerical value of a quantity is the number that shows how many times the unit is taken. Numerical value. And we learned that a number is an expression denoting a unit or collection of units in a quantity. So a number expresses the number of units present in a quantity. We learned that there are two kinds of number, abstract number and concrete number. Concrete number includes the unit of measure. Abstract number is a number with no reference to a unit. So if I have the number 26, is the number 26 an abstract number or a concrete number? Is the number 26 abstract? It's abstract because there's no unit. This is very simple. Abstract has no unit. If I say the tree is 30 feet tall and I have this number, 30 feet, is that abstract or concrete? Concrete. All right, so if we include the unit, we have a concrete number. If there's no unit and we just refer to the value, the number itself, that's an abstract number. Okay, good. We learned in Article 11 that in algebraic computations, in algebra, letters are used to represent numbers. In algebra, letters are used to represent numbers. Let's see how smart you are. Why do we use letters? Why do we use letters to represent numbers in algebra? Why do we use letters to represent numbers?
Make it more simple.
What do you mean by simple?
Make it not as complicated.
How is it complicated? What makes it complicated? What are we trying to get rid of?
Like it saves like a whole sentence.
Okay, what you're thinking about, I see what you're saying. You're thinking about the use of letters to make formulas. That's what you're thinking about, right? When we learn that a formula is a way of expressing a mathematical idea, right, or a rule, and we can do it with words. We could write out the formula in words, or we can use symbols to write a formula. That's what you're talking about. I was actually thinking about something else. Why do we use letters in algebra? Remember in our first lesson I explained that in algebra we're talking about situations where quantities can change. Remember we talked about that, right? We're talking about situations where we don't necessarily know the value of the quantities. The quantities can change, and so we use a letter to simply represent a certain quantity, a quantity that can change, a quantity that may be unknown. All right? So in algebraic computations, letters are considered as representatives of numbers. We learned that there are two kinds of questions in algebra: theorems and problems. Theorems and problems. In a theorem, we're required to demonstrate a truth. We're required to demonstrate something to prove that something is true in a theorem. In a theorem, we're required to demonstrate that something is true. In a problem, we're required to do something. We're required to find the value of some unknown quantity. So in a theorem, just to keep it very, very simple, in a theorem we need to prove something. In a problem, we need to find or do something. In a theorem, we need to prove something. In a problem, we need to find or do something. Two kinds of questions in algebra. That brings us to Article 15, which is a definition of algebra. Algebra is a general method of solving problems and demonstrating theorems by means of figures, letters, and signs. Algebra is a general method of solving problems and demonstrating theorems by means of figures, letters, and signs. That's articles 1 to 15. That's what we covered in lesson 1 of Algebra 1, articles 1 to 15. In our second class, we got started with lesson 2, and we covered quite a bit of material. We covered articles 16 through 32. And the reason why we got through so much of that material, just pay attention. Just pay attention. You don't need to worry too much about your notes. The reason why we covered so much material in our second class was because these articles from 16 through 32, most of them were just about the signs. Remember? The addition sign, the subtraction sign, the equal sign, the multiplication sign, the division sign. And we moved through that material pretty quickly because most of it is simple and we already know those things. So we moved through the articles on the signs. We talked about positive and negative numbers. We talked about what it means to have like signs when two quantities have the same sign. They're both positive or they're both negative. We talked about unlike signs when one is positive and the other is negative. And the reason why we learned that in this lesson is because later on when we learn some rules are going to depend on whether the signs are the same or different. If the signs are the same, there's going to be one rule. If the signs are different, we're going to find there's a different rule. That's why that's important, okay? Sign of multiplication, and then we learned some vocabulary. We talked about factors. Factors, we said any quantities that are multiplied together are called factors, right? Any quantities that are multiplied together are called factors. We then learned the sign of division, the sign of inequality. The sign of inequality means greater than and less than. Do you remember the sign of inequality? Greater than and less than. If I have A is greater than B, this is the sign of inequality. And it is read as A is greater than B. And if the sign is in the other direction, like that, it's read as A is less than B. The inequality sign, we said, opens toward the greater number. So we learned about the sign of inequality. We learned about the sign of infinity, which is like a sideways 8. The sign of infinity, which means a quantity that can't be numbered. It's infinite. We then talked about coefficients, and this is where I think I'd like to pick up with this lesson. I want to make sure that we didn't go through this too quickly in our last class. So we'll pick up at Article 30, I believe it is. We'll review this as if we never studied it before. We'll pick up at Article 30 here on the numeral coefficient. And you'll probably agree that that wasn't too clear in our last class. We moved through it pretty quickly. So let's just go through it again, take our time, and make sure we understand what coefficients are, numeral and literal coefficients. So we were talking about, so the third part of our lesson today will be a review of, a more specific review of Articles 30 through 32, and then we'll get into our new material. We talked about multiplication. We talked about factors, numbers that are multiplied together. So if I have the quantity 4a is equal to 4 times a. Right? 4a is equal to 4 times a. we say that these two quantities, 4 and a, these quantities are being multiplied together, and therefore they're called factors. They're called factors. Any quantities multiplied together are called factors. We said we can also call them coefficients. Coefficients. And this word is used, and it's good for us, at least to get a general understanding, it's good for us to just think that coefficients and factors are synonyms. They mean the same thing. Factors and coefficients. Quantities that are being multiplied together. Coefficients. Make sure you get this word clear, coefficient. We're going to see it all through our study in algebra. Make sure you're not confused by this word later on. Coefficients are just quantities multiplied together. Coefficient, coefficient, coefficient. Numbers being multiplied. We said that there are two kinds of coefficients, and this is in Articles 30 and 31. There are two kinds of coefficients. In this expression here, this expresses a multiplication problem, 4 times a. The number 4 is a coefficient of a. Please follow me on this because I want to make sure this is clear. 4 is called the coefficient of a. It's the number that it's multiplied together with. The way that, remember we talked about algebraic language? Formulas are expressed in algebraic language. This is the algebraic language. We have to learn the language of algebra. All right? 4 is the coefficient of a. It's the number that's multiplied with it. 4 is the coefficient of a. 4 is the numeral coefficient. We have to get our vocabulary up to a higher level so that we can begin to communicate in algebra. 4 is the numerical coefficient of a. That's a numeral coefficient or numerical coefficient. Now, if we have another expression, I don't want to use x. That's always confusing. If I use CD, in algebra, CD means C times D. Because when we set two quantities together, that expresses multiplication in algebra. This is the language of algebra. All right? When two quantities are written together, it's an expression of multiplication. CD is read as C times D. Some quantity C, we don't know the quantity, we don't know what the exact number is, but we're calling it C. We're using this letter to represent the quantity. We don't know what it is. Multiplied by some other quantity that we're going to call D. We don't know what it is, but we're going to use the letter D to represent this other quantity. And this expression means the quantity C times the quantity D. All right? We're learning the language of algebra. The quantity C times the quantity D. That's how this should be read in your head. You can just say CD, and if you know algebra, you know that CD means the quantity C times the quantity D. Right? So like I said yesterday, if we take Einstein's famous formula, this is read as E equals mc squared. That's how it's read. It's a formula. E equals mc squared. C squared, as we're going to learn later today, C squared means C to the second power, or C times C. So this is the same thing as saying MCC. M times C times C. the quantity m multiplied by the quantity c multiplied by the quantity c again. That's an example of algebra in a formula. And we see here quantities written side by side. That expresses multiplication. CD means C times D, or the quantity C times the quantity D. In this expression, C is the literal coefficient of D. Here, 4 and A are coefficients. They're multiplied together. 4 and A are coefficients. 4 is the numeral coefficient of A. Here, C and D are coefficients. They're factors. They're factors of each other. They're coefficients. But C is the literal, that means a letter, literal coefficient of D. Got that? So we have two kinds of coefficients. This is the kind of stuff that gets kids hung up on algebra. You just have to learn a language. And some kids just tune out when the language changes and they struggle. It's got nothing to do with math. It's got to do with language and vocabulary. Coefficients are numbers or quantities that are multiplied together. A coefficient can be a number, a numeral coefficient, or a letter, a literal coefficient. 4 is the numeral coefficient of A. C is the literal coefficient of D. All right, coefficients. Sometimes these can get more complicated. We can have something like, I don't want to use X, 4AB. 4AB. This is a little more complicated because look, I can say the quantity 4 is the numeral coefficient of AB. Right? 4 is the numeral coefficient of AB. Or I can say that 4A is the coefficient of B. Because all three of these are multiplied together. 4AB is equal to 4 times A times B. All three of these quantities are coefficients. So I can say 4A is the coefficient of B. I can say 4 is the coefficient of AB. So sometimes it will get more complicated. But what I want you to understand is what this word coefficient means. It means numbers that are multiplied together. That's it. It's not more complicated than that. That's articles 30, 31, and 32. All right, so that brings us to Article 33, which I intended to be a new content in this class. All right, so we've reviewed Articles 1 through 32. Hopefully you understand what coefficients are. That was the last part of our last class that I wanted to clarify. Our time is 24 minutes, so we have time to get through Articles 33 through 38. Now, this is important. These articles are important because we're going to talk about powers, exponents, and roots. So in your notes, let's label this next section in your notes powers, exponents, and roots. Powers, exponents, and roots. And I'll try to make this as simple as I can. Powers, exponents, and roots. Articles 33 through 35. Powers, exponents, and roots. So what is a power? What is a power? Our textbook tells us the power of a quantity is the product, that means the result of multiplication. Pay attention with me. This is an important lesson in math. The power of a quantity is the product arising from multiplying a quantity by itself. So a power is the product. A power is a kind of product. If I have 3 times 4, these are the factors. The product is 12. Okay? The result of multiplication is called a product. So when you see this word product, that's what we're talking about. We're talking about the result of multiplication. Don't get confused by the vocabulary of algebra and mathematics. The product is the name of the result of multiplication. 3 times 4 equals 12. 3 and 4 are factors. 12 is the product. That's regular multiplication. If we had AB equals X, this is multiplication. These are factors. X is the product. X is the product of A times B. The product is the result of multiplication. That's simple enough, right? Now, all we're learning in Article 33, what happens when we multiply a number by itself? If instead of multiplying 3 times 4, we multiply 3 times 3, we get 9. That's simple multiplication. But this is called the second power of 3. This is the language of algebra. So listen to the rule again. The power of a quantity. So 3 is the quantity we're talking about. The power of a quantity is the product. The power of a quantity is the product arising from multiplying the quantity by itself 1 or more times. So 9 is the second power of 3 because we're multiplying 3 by itself. Right? 3 times 3. This is called the second power. 3 times 3 is 9. The second power of 3. If I did 3 times 3 times 3, 3 times 3 times 3 would be equal to 3 times 3 is 9, and 9 times 3 is 27. 27 is a product of this multiplication. But because I'm multiplying this quantity by itself, 27 is called the third power of 3. So you have to understand what's meant by this term power. A power is a kind of product. A power is a kind of product when a quantity is multiplied by itself a number of times. A power is a kind of a product when a number or a quantity is multiplied by itself a number of times. This is a product. 3 times 4 equals 12. Is this a power? No, because we're not multiplying a quantity by itself. 3 times 3 is 9. This is a product. Is this a power? Yes, because we multiplied a quantity by itself a number of times. This is a certain kind of product, a power, when the factors are the same quantity. Okay? The factors are all the same quantity. So that's a power. Keep that in mind. The power of a quantity is the product that arises from multiplying the quantity by itself one or more times. When the quantity is taken twice as a factor, the product is called the square, or the second power. So if I have a quantity A times the quantity A, this product is called the square of A, or the second power of A. So a square, and this is algebra, we're not talking about geometry squares, okay? This is just a term used in algebra. A square is the same thing as a second power. You got that? A times A, any number multiplied by itself. So there are two factors. That's called a square, or the second power. So 6 times 6 is 36. 6 times 6 is 36. 6 is taken twice as factors. This is the square of 6. This is the second power of 6. You understand that idea? Second power. This is just vocabulary. So when I say, do you understand that? I'm just saying, do you understand the meaning of the word? There's nothing to understand. We're just learning vocabulary. If we multiply a quantity by itself, that's called the square of that quantity. Got that? So back to our lesson 33 here. When a quantity is taken twice, the product is called the square or second power. When it is taken 3 times, it's called the cube or the third power. And this is just vocabulary. There's nothing to understand, no magic. If we take A times A times A, this is called the cube of A, or the third power of A, because the quantity A is multiplied by itself so that it's taken as a factor 3 times. When it's taken 3 times as a factor, it's a cube or a third power. When it's taken 2 times as a factor, it's a square or a second power. And you've heard this phrase. You've heard the phrase like the formula I showed you. E equals mc squared. We're going to learn what this means when there's a little number written like this. E equals m, listen, c squared. What that means is E equals m times c times itself. C taken as a factor 2 times. We're going to learn that that's what that little 2 means. All right? C taken 2 times. So you need to learn what a square is, that a square is a second power, what a cube is, that a cube is a third power. You better have that in your notes. What a power is, okay? Thus, A times A is the second power of A. A times A times A is the third power of A. A times A times A times A, taken 4 times, is the fourth power of A. That's what power means. Next in our lesson, we're told that an exponent is a figure placed at the right and a little above the quantity, an exponent. An exponent is a figure placed to the right and a little above a quantity to show how many times it is taken as a factor. So an exponent is a figure that's written to show how many times a quantity is taken as a factor. So if I had A times A equals A, and I could write an exponent like this, it's written a little smaller to the right and above the quantity. This expression means this: A taken twice as a factor. Okay? A to the third equals what? What is A to the third power? Or A cubed? A cubed, or A to the third power. What does that mean?
A times 3.
No.
A times itself.
A times itself 3 times. A times A times A. If I have A to the 5th power, what does that mean?
A multiplied by itself 5 times.
5 taken as a factor 5 times. A times A times A times A times A. That's A to the 5th power. That's how you read that. If you see this, it's A to the 5th power. A to the 2nd power. A to the 3rd power. That's how you read that. Okay? This is read as A to the 2nd power, A to the 3rd power, A to the 5th power. And all it means is A taken 2 times. All this means is A taken 3 times. A taken 5 times. So if I have the number, what does that mean?
4 multiplied by 2.
No, not 4 multiplied by 2. 4 taken 2 times as a factor. Okay? We can read this as 4 squared. We can read this as 4 to the 2nd power. And what it means is the multiplication of 4 times 4. And what's 4 times 4? 16. So 4 squared equals 16. 16 is 4 to the 2nd power. 16 is 4 squared. Okay, so what I want to make sure you have in your notes, obviously we're going to talk about this and review this a million times, but what I want you to have in your notes is we were taught what the word power means, right? Power, what 2nd power means, what 3rd power means. And I want you to know what square means, okay? It's in your notes. Square and cube. Square is the same thing as 2nd power. Cube is the same thing as 3rd power. After the 3rd power, we don't have other names. There's just square for 2nd power, cube for 3rd power, and then after that we just say 4th power, 5th power, 6th power. All right? So know what a power and an exponent is. Now, if we have a quantity with no exponent, just a quantity written by itself, like this, we can understand an exponent. There is an exponent that goes with this, and the exponent is 1. So A is the same thing as A, we could say, to the first power, if that makes any sense. Okay, but when a quantity exists by itself, we can understand it as having 1 as an exponent. That may seem dumb, right? That may seem dumb, but later on, we'll understand why that's important. Okay? So just know that. Just know that A is the same thing as A with the exponent of 1. Okay? Doesn't make sense now, but it will make sense later. Article 34. To raise a quantity to any given power is to find the power of the quantity. To raise a quantity to any given power is to find the power of the quantity. This is just teaching you the language of algebra. To raise the quantity to any power is to find the power of the quantity. So if I say, find the second power of 4, find the second power of 4, what I mean is multiply 4 times 4 and find the product. If I say, find the third power of 3, find the third power of 3, I mean find the product of 3 times 3 times 3. Find the power. Okay? Find the second power, find the third power, and so on. This is the language of algebra. You got that? Find the fifth power of 4. What would you do? Find the fifth power of 4. What would you have to do? Find the fifth power of 4.
5 times. 5
Multiply 4 by itself 5 times, right? Use 4 as a factor 5 times. Find the fifth power of 4. Okay, that's Article 34. Now, the opposite of this is a root. Okay? So we have powers, exponents, and roots. Do you know what a power is? Yes, right? Do you know what an exponent is? Now you know what an exponent is? Now we're going to look at roots. Roots are the opposite. Okay? The definition of a root. The root of a quantity, just listen to this. The root of a quantity is another quantity, some power of which equals the given quantity. That's just mumbo jumbo. Right? It's a very confusing way to express this idea, but it makes sense if you take it apart slowly. The root of a quantity is another quantity, some power of which equals the given quantity. So let's see what this means. The root of a quantity. The root of a quantity is some other quantity, some power of which equals the given quantity. So let's say we have the number 25. And I ask you, what is the square root of 25? The root is the number, let's use the number, we'll use the quantity A. If I ask you, what is the square root of 25, what I'm asking is, what quantity multiplied by itself produces this quantity? What is the square root of 25? What number multiplied by itself equals 25? What's the answer? 5, okay? So we know that 5 times 5 equals 25. So 5 is called the square root of 25. So the root of a number is the number that multiplied by itself a certain number of times produces that quantity. if I have the number 27, and I asked, what is the cube root of 27? What is the cube root of 27? When I'm asking you, what is the cube root? That means what number multiplied by itself, taken as a factor 3 times, produces 27. This quantity A is the cube root of 27. If I asked you to find that number, what would it be? You know?
9.
No. What number multiplied by itself, taken as a factor 3 times, equals 27? Not 9. 3. 3 times 3 makes 9. Times 3 again makes 27. So 3 is the cube root of 27. So you see what a root is? A root is a number or quantity multiplied by itself a certain number of times to produce another quantity. The power is the product. You got that? The root is the factor. The power is the product. The root is that factor. Multiplied by itself a certain number of times produces that power. Roots and powers. Okay? Let's try another one, just to make this clear. If I took the number 81, and I asked you, what is the square root of 81? What is the square root of 81? What I'm asking is, what number multiplied by itself equals 81? What is the square root of 81?
2.
No. You just answered. What is the square root of 81? What number multiplied by itself makes 81? 9 times 9 equals 81. 9 is the square root of 81. 81 is the second power of 9. All right? Square root, cube root. And when we find a root, our book tells us that's called extracting the root. Article 37 teaches us how to write this. All right? So if I want to write a power, if I write a to the second, that means a to the second power. If I write a to the 14th, that means a to the 14th power. A taken as a factor 14 times. We use exponents. We use exponents to express powers. Right? To express a root, we use this symbol. It's called a radical sign. The word radical just means root. Radix in Latin means root. This is called the radical sign. So if I put the radical sign with the quantity 16, what I'm asking is, find the square root of 16. Find the square root of 16. What number multiplied by itself makes 16? What number multiplied by itself makes 16? What's the answer?
8 times 8.
No.
4.
4. The square root of 16 is 4. The square root of 16 is 4. 4 times 4 makes 16. Okay? If I want to ask for the cube root, what number taken 3 times, instead of writing the radical sign by itself, I'll write the radical sign, but I'll put 3 there to show what I want is the cube root. Okay, the cube root. So if I said, what is the cube root of 8? What I'm asking is, what number taken 3 times as a factor produces 8? And the answer is 2. 2 times 2 is 4, times 2 is 8. 2 is the cube root of 8. Okay? Anytime we see the radical sign by itself, we understand that it's got a 2 inside of it. It means the square root. Find the square root of 25. What number multiplied by itself twice gives us 25? 5. The square root of 25 is 5. That's how you read this. The square root of 25 is 5. The cube root of 27, what number taken multiplied by itself 3 times as a factor makes 27? The answer is 3. 3 is the cube root of 27. You have this all in your notes? The radical sign asks for the square root. If we add a number to the radical sign, it changes the root that we seek. Article number 38 tells us what that little number is called. Article 38 says the number placed over the radical sign is called the index of the root. So this little number here is called the index. The index is that number placed over the radical sign. Actually, put 16 in there. If I wrote this, I would say, what is the 4th root of 16? This little number is called the index. This symbol is called the radical sign. Okay? So in these articles so far, we've learned a number of different terms. I should say powers, exponents, roots, and indexes. Okay? That includes all the terms that we've learned. Powers, exponents, roots, and indexes. That little number over the radical sign is called the index. That takes us through Article 38. Let's just quickly review this. Time-wise, we're at 54 minutes, so we're doing okay. So if I take a squared equals, and I just make up a quantity, let's say y. Y is the second power of a. Pay attention. Y is the second power of a. This is called an exponent. This is the second power of a. This is an exponent. If I ask for the square root of y, this is called the radical sign. The radical sign represents a root. If I have a small number that indicates what root I'm asking for, This little number is called the index. This is the radical sign. It asks for a root. The index tells us what root we're looking for. You got that? So we've learned powers, exponents, roots, and indexes. I shouldn't say indexes. The plural is actually not indexes, it's indices. Indices. The singular form is index. Okay? That takes us through Article 38. I can tell we're going to need to review this a little bit in our next class, so we'll wrap up here with Article 39. Oh no, I'm sorry, 38 was our planned end. So we'll wrap up there with powers, exponents, roots, and indices. That takes us through Article number 38. That takes us to the end of Lesson 2. Take your notes back out. We're not finished yet. To finish your notes for the class, I want you to take a minute and write a brief summary of what was covered in the lesson. A brief summary of what was covered in the lesson. Every time you finish a lesson, you should wrap up all of your notes and write for yourself a brief summary of what we covered in the lesson. Think about it. Get it all in your head. What did we study in this lesson? You can look back over your notes. You can see what we covered and write a brief summary of the lesson. So that leads us through the end of Article 38, which is Lesson 2 in the Classical Liberal Arts Academy's course in Algebra 1. And that wraps up this class, this third class in Algebra 1.